Okay, let's look at the next infographic from Ocean Visions, which is about electrochemical ocean carbon dioxide removal. What happens here? So you have steps that involve processing, and there are places where you do the storage, and then the input to the process is the seawater itself, and of course you need energy. Then you are producing an acid, which is a process, and you have to understand that energy is involved everywhere. So this whole system shown, nice schematic and outflow to produce acid. So you basically have lower pH here, and you produce a base. So you obviously have taking pH from one part of the fluid that you are taking in and moving it to another part, and then putting the higher pH water into the ocean, as we said, with the alkalinity enhancement. And this one will go into stripping CO2 from seawater and sequestering CO2 in a geologic reservoir, and the other arrow line goes into adding alkalinity to replace alkalinity neutralized by the acid, and then again you take up more CO2 by enhanced alkalinity and discharge CO2 depleted seawater to draw down atmospheric CO2. So that's another storage term as well. So there are details with each of these in the document, but I'm just going to use the info brochures, infographics to discuss these. So if you want to follow up, you can follow up. So the other part with the base fluid or enhanced alkalinity, again, you discharge seawater with elevated alkalinity to draw down atmospheric CO2, which is going here near the, I'm not sure these are meant to say where they are released, but just schematically they are released into the water, typically coastal waters, I suspect, with elevated alkalinity to draw down atmospheric CO2. So the message is alkalinity, it's not just pH. Alkalinity is the combined neutralizing ability of all the different H plus sources in the ocean, which we will look at in a minute. Actually, I should have done that, but I have podcasts elsewhere on alkalinity that you can look up. We talked about in the carbon cycles as well. And the other pathway goes to precipitating carbonates, CaCO3, and add alkalinity to replace alkalinity that is lost during carbonate formation. So Ca plus and plus CO3 minus, you can look up the reactions. Basically, you are always moving pH or alkalinity around. Better to talk about alkalinity. And then again, you are discharging rebalanced seawater. So that this process on the whole is only enhancing alkalinity and drawing down CO2, or you are discharging rebalanced seawater through the processes, so that you are not you are not reducing alkalinity in any way, but obviously you are increasing CO2, but there is a acidification that is happening because of CO2 dissolution. So you have to track to make sure that pH is going down in the ocean by increased CO2 in the atmosphere. So we are increasing alkalinity to by adding increased pH water or enhanced alkalinity water as well. Okay, so you also strip CO2 from the seawater and sequester CO2 in the geologic reservoirs, and the precipitated carbonates are taken up as building materials. Cement production uses massive amounts of calcium carbonates, the clinker process, which is very energy intensive, but that's a different problem there. So here produced acid is neutralized with alkaline materials as well, and you are also off-taking for industrial use. So it's kind of a CCUS, carbon capture and utilization, carbon capture and sequestration, the method being electrochemical ocean carbon dioxide removal. They separate this from the alkalinity enhancement for whatever reason that we'll come back and look at. Okay, basically because you are processing the seawater extensively here to produce waters with enhanced alkalinity, and you have additional steps where you are stripping CO2 out of the water as well as neutralizing pH to put it back into the ocean, and putting enhanced alkalinity water into the ocean to enhance CO2 uptake, and so on and so forth. Okay, these are few things. Follow up with details if you are interested in interested in further details, let's say. Okay, see you in the next Ocean CDR topic.